Hello, and welcome to another video presentation, courtesy of the University of North Texas Physics Department, with the assistance of the Physics Demo Room. My name is Corey Nutt, and I'll be helping assist with today's demonstration. Today's demonstration tries to illustrate the concept of Newton's third law, of that the action and reaction occurring is equal and opposite. So with this, we kind of think about it's really hard to see physically these kind of action-reaction forces. Because most of us might think, well, if it's an action-reaction, I use my feet to walk. I push off the ground. That's why I move forward. Well, for those of you that might have lived in a state where there's snow and ice on occasion, well, why doesn't it work when all of a sudden you have snow and you have ice in particular, and you try to push off from that? You don't move as far. That's because you're not able to actually have the earth push you back, which allows you to move forward. You're now slipping. There's no force back. You're pushing, but there's nothing going on to push you back. So even though you might try to apply a force, there's no force applying back to send you forward. So we also think about this sometimes if you've seen some very interesting YouTube videos of about two people about equal size have giant exercise balls, and they run at each other and they hit each other and they both bounce back with the same amount of force. Now sometimes you might see and be like, well, in this one instance, one guy stood still and the other person bounced away. Well, maybe that's because when they were about to collide, the other person grounded themselves instead of jumping in the air, which means now there's no extra force involved. So that's where, with that, you have to look at a little bit of what else is going on and not just at one little instant. So in this case, to help illustrate this action-reaction forces, is that we have a dynamic track in front of us, and I have two Pasco dynamic carts. One of these carts is just plain cart, rolls on pretty much close to frictionless. Now, if you notice, this other cart has a plunger that's coming out of it. What I can do is I can set this plunger when it wants to work with me, and it no longer sticks. I hit the top, and a plunger will come out. This is to help simulate a push that one object is going to exert on the other. So now, in reality, if I didn't have any friction or if I didn't have anything to help stop me, when I push something, I would be pushed back. This is what happens sometimes if you were to think about it. If we were in space and we had an object and we threw it, the amount of force we tried to throw the object would push back on us and we would go in the opposite direction. Similar to what you might see on ice rinks too. So with this, if I was to release this plunger and have it push this cart, the cart's going to push back with the same amount of force, so these two should split and look like they're going to have the exact same speed. So now if I tap the top of this to hopefully not add any additional force in the X or Y direction, these two should plunge apart and go at the same direction, same speed. Pretty close. So this is a concept that if we don't have any friction and we just start looking at the interaction of two objects and whether or not they're going to actually have the same speed once I release that. Now it's probably a little bit, as you can see, it's not perfect because I've got a little bit of a tilt here. So it means that my angle is going to be a little bit off, so I need to kind of hold it to about here. And now let's try it again. And don't lose this cart off the track. So these two moved approximately with the same speed, giving us more visualization that for every action there's an equal and opposite reaction. That if I push on someone, they're pushing back on you at the same amount of force. So, well, thank you for this video presentation and for watching, and have a wonderful day.